Today's lesson is on solving a system of equations algebraically. A system of equations is a set of two or more equations with the same variables. A system of equations can be solved with one solution, a coordinate pair that satisfies both equations, no solutions, or infinitely many solutions. Here's two equations. These equations could be graphed like we did in our first lesson in 9-6, and we would find where these two lines intersect. In this case, we're going to discover which point intersects just by using algebra. To find the point where these two lines intersect, we substitute the given value for y into the first equation. Notice it gives us a value for y. It says y equals 5. We're going to take that value of 5 and substitute it over the y. So instead of saying y equals, we'll say 5 equals x plus 2. In the next step, we're going to solve for x. So we set up 5 equals x plus 2. Subtract 2 and x equals 3. Finally, we write our solution as a coordinate pair, x comma y, so we write it as 3 comma 5. In this example, the y is not isolated. We have y minus 3x equals negative 13. So our first step is to isolate a variable. We're going to isolate the letter y because it has no coefficient. To isolate y, we're going to move the negative 3x by adding 3x to both sides. When we do that, we get y equals negative 13 plus 3x. Our next step is going to find the value of x by substituting the new value that we found for y into the other equation. The second equation, 4x plus 5y equals 11. We can only solve for one variable at a time, so we're going to substitute negative 13 plus 3x where we see y. When we do that, we have 4x plus 5 times parentheses negative 13 plus 3x equals 11. Next, we'll do distributive property. 4x minus 65 plus 15x equals 11. We'll combine our like variable terms. 19x minus 65 equals 11. And then we'll undo the subtraction with addition. 19x equals 76. Next, we can undo the multiplication with division. This shows that x will equal 4 when we substitute the value for y into our second equation. After we've solved for x, we can take this value for x and plug it into either of the equations that we started with. Let's look at y equals negative 13 plus 3x, and we'll substitute x equals 4 into this equation. So we have negative 13 plus 12, y equals negative 1. The last step is to write the solution as a coordinate pair. X comma y, or 4 comma negative 1, is our solution. If we're to take the numbers 4 for x and negative 1 for y and substitute back into either of those equations, we'll see that this coordinate pair satisfies both equations. We have two more equations here, y equals x plus 5 and 2y minus 2x equals 10. In these two equations, you'll see that the first equation already isolated the variable y. So we isolate the y and we see that y equals x plus 5. If we take this value for y and we substitute it into the y in the second equation, we see we can use distributive property to solve. 2 times x plus 5 in parentheses minus 2x equals 10. So we have 2x plus 10 minus 2x equals 10. Notice 2x minus 2x cancel out and we're left with 10 equals 10. When we have identical numbers on both sides of the equal sign, then we know the system has infinitely many solutions. In other words, whatever values we have for x or y in our coordinate pair, they will both be satisfied in each equation. Here's another example. Y equals x plus 5 and 2y minus 2x equals 8. Again, we see that the y is already isolated, so we'll substitute the value for y into our equation. 2 times x plus 5 minus 2x equals 8. In this example, we have 2x plus 10 minus 2x equals 8. Again, the 2x minus 2x cancels out, but this time we have 10 and it does not equal 8. Because both numbers on integers on each side of the equal sign are not equal, then we have the system has no solution. When you have two different integers on each side of the equation, the system has no solution. Sometimes we'll have word problems, and when we're writing a system of equations from real-life situations, we need to first define the variables. So we read the problem. Manny scored a total of 24 points in 2 ball games. In the second game, he scored 3 times as many points as in the first game. Write and solve a system of equations to represent this situation. Interpret the solution. We let x equal the points in the first ball game. So we know there's 2 ball games. So we have x be the first ball game and y be the second ball game. Next, we're going to read the problem carefully to find the relationships between these 2 variables. It says Manny scored a total of 24 points in 2 ball games, which means x plus y equals 24. In the second game, he scored 3 times as many points as in the first game. Well, y is the points in the second game, so y equals 3 times the number of points he scored in the first game. So these are our 2 equations that we will set up to solve. Our next step would be to substitute and solve for the values of x and y. So if we substituted 3x for y, we'd have x plus 3x, or 4x equals 24. In this situation, x would equal 6, and y would equal 18. So 6, 18 satisfies our solution. In other words, he would score 6 points in the first game and 18 points in the second game. In summary, a system of equations can be solved algebraically with substitution. A system may have one solution, no solutions, or infinitely many solutions. To solve algebraically, isolate a variable. Substitute the value for the isolated variable into the other equation to solve. If the system has one solution, write the solution as an ordered pair, x, y. If the outcome on both sides of the equal sign is identical, the system has infinitely many solutions. If the integers on both sides of the equal sign are different, the system has no solutions. When solving a real-life situation for a system of equations, remember to define the variables. Write equations for the relationships between the variables, and solve for each variable using the substitution method. I hope this was helpful.